Today we have the computer out of a Ford pickup truck, usually 94 through 96. The part number we have is F4TF-12A650-AMA. Shop dropped this off, so we're going to take a look and see what we can find on this. This is one we're not able to test on the bench, but we've learned looking at a lot of things we find problems just by looking, or find the problem just by looking. We're going to remove two screws from this case. They are T15 screws on each side, and we're going to take these screws out and set them to the side. Now we're going to remove the top cover, remove the bottom cover. We're going to take a close look at what we have here now. On first examination, what we commonly see in these radios, or not this computer, but in a lot of electronic equipment that we do see, we have problems with capacitors, electrolytic capacitors. And if you don't know what to look for, it's kind of, you don't recognize it. But what we have here in this particular radio is one electrolytic capacitor here, one electrolytic capacitor here, one loose electrolytic capacitor here. This one here has a broken leg on it. This one has a broken leg on it. And we have the third one over here also has a broken leg. So these three components aren't making contact. We also have a tantalum cap over here on the side. We'll get into that in a little bit. But the problem with these units is the electrolytic capacitors leak acid, and you can see here in this particular case where this computer must sit in a certain position, but we have the leakage has gone down along the circuit board traces. Here under this component here, you can see how the board is discolored and has gone down under these towards the two components here. But on this third electrolytic capacitor, this one is causing a lot more damage, because we can see that the leakage has come up to the processor. The board is all discolored. Looks like we got an open circuit board trace here as well from the acid eating up the trace, and goes down below here. What we're going to do is draw a layout of the three components we need to replace before removing them, so that we can get them right. I've enclosed the picture of the drawing here, color-coded. This will allow you to know what components to get, which ones go back in, and so on. So, since we've drawn up the map, we've located our three components we need, and we're going to replace these. But we're going to unsolder these components, clean the circuit boards up, see if there's any open traces. We may need a couple of jumpers in here because the traces are all eaten up. But that's going to take care of it. Let's see what we get here when we're done. When we finish here, we'll just unsolder these capacitors to begin with. There's one missing a leg. You see the leg is there on the second one, on the second leg. So we're going to grab that leg here, okay, and see if we can unsolder it from the back and pull it out. We don't want it to get sucked up through the solder sucker here, because then we'll have to clean that out. And there we go, we have one of the legs. Now we're going to repeat this process for all three of the capacitors here. We're going to start with that really ugly one down here. And we're also going to remove that tantalum cap, which I mentioned, that sits next to this electrolytic capacitor. And that one sits right here. Now there is a trick to the how these capacitors go back in. On the diagram we had a plus and a minus on the front. In the diagram we drew for the layout, we have we've put the polarity in on the drawing, and these components do have a polarity which have to go in the same direction. The whole reason for making the map. Now we have two of the electrolytics removed, and the tantalum here. This is going to help when it comes to cleaning up this area. We'll have a little bit more room. And now we're going to try the remaining capacitor over here, which happens to be, okay, right here. Now that was the broken leg. That one's still remaining in the hole. Okay. Okay. Okay, come on. There we go. Oh, this one's in bad shape. Doesn't want to release the capacitor. There we go. Anyways, one leg on these 3 capacitors. Now the capacitors, usually when they come, the value is written on the side. We're going to have 240s. We have, where'd they go here? We have 247s and a 100. 247s and a 10 from the drawing. And when we did our drawing, we put a plus mark next to the positive side. On the electrolytic capacitors here, they are marked. They do not mark the plus side, but they mark the negative side with a negative sign down one side of the component. And this will tell you which side is negative, so you'll know the positive is the other leg. Most capacitors have 2 size legs. The longer is usually positive. That helps as well. The tantalum cap is a little bit different. This is the tantalum cap. And if you look at the face of that, you can see some numbers and a line that goes down one side of it. Now the line on this particular capacitor marks the positive side of this component. So it's a reverse of being marked on the electrolytics. But check that when you get that back in. Make sure you get that in the right direction as well. So now we're going to clean this board up and see what we come up with. Now it's taken, according to the timer, about 15 minutes to get to this point where we're at right now of cleaning the board up. We have a fiberglass sanding pen, which allows us to rub the board and clean it up. And if you remember where all the leakage was earlier, we've cleaned up this spot of the board here. You can see, hopefully it's a nice shiny copper, so we can check to see that all our traces are good as well. We also lifted 2 more components so that we could clean the leakage that was under this capacitor as well. The third capacitor here in the titanium cap that sits here, we had some problem cleaning up around in here because it was in towards the legs and so on, but we did a pretty good job in here. I don't know if you noticed, but we do have one open trace from a point right here, right down, right next to where the capacitors were sitting, to another point here. It is an open trace. We're probably going to put a jumper in across there and do that next, and then put the components back in the circuit board as well. Let's see if we can take care of that next. And alright, we're back with the cleaning up. We've got the 2 components that we lifted the legs on to clean under soldered back into the circuit board. I don't know if you can tell, but we mentioned an open trace over here, and with the components, we saved the legs on the components and they took the path of the same trace. You can put a jumper in from one side to the other, or you can come to the back and put a jumper in from this side if you match the points up. But now we're going to stuff the board back up. Okay, now we've repopulated the board. We got our electrolytic caps in and replaced the tantalum cap. But as we were soldering this cap in, we noticed that the ground connections on the top, there's a connection from the top of the board that goes to the bottom of the board, that at the top here it wasn't making contact. So we had to add another jumper from up here, another leg from ground down to the leg of the capacitor as well to cover that, complete that circuit. We're going to put this together, see how it happens. This is usually about an hour repair. This takes care of the problems that we physically see. Although these components can cause other components on the board to go bad, we're unable to test this on the bench. So see our website for any other do-it-yourself repairs, along with stereo repairs and other units, removal instructions, and so on. We're going to get these 2 covers back on. They go one way only. And place the 2 screws we had here. Again, see our website for any other help you may need on these computers. We'll be posting those in the future as well. Hope this video has been helpful. Hope this takes care of the problem you have. In many cases it will, not all. Thank you for watching. We have a full library of removal guides on our website, along with a lot of do-it-yourself repairs.